Oh yeah, welcome back to Gallant Tutors Academy. In our previous video, I actually taught you guys about chemical bonding, and I focused more on the interatomic bonds, which includes ionic bonds, right? Ionic bonds, covalent bonds, and I told you that under covalent bonds we also have a kind of bond known as coordinate covalent bond, or otherwise known as dative bond, right? And I also discussed about metallic bond. So in this particular video, we'll be talking about questions on metallic and what dative bonds, right? Metallic and dative bond. That's what we'll be centering on this particular video. So if you are new here, you know the right things to do, right? Subscribe, like, and share if you like to share, right? But it's not compulsory to share, but then ensure you subscribe, and so that you'll be able to see our future videos, right, earlier than others. Okay, let's dive in. So the first question is here already. They said, and it says that I can hit a metal with a hammer, all right, without the metal shattering because of it dash. So before we answer this question, I would like to know if you really understand what they are actually trying to ask, like the question they're actually trying to ask us, right? When they say shattering, what does that mean? This shattering means what? It means breaking, basically, right? It means breaking. And a very good example of that is a cube sugar, right? Cube sugar. So this is how a cube looks like. In short, this is how a cube sugar looks like, right? I'll have atom, smaller stuff here. So when we put this in water, or if we use a hammer, for instance, to hit it, what do you think will happen? It will break to become what? Granulated. Do you get that? This particular stuff, this particular structure has shattered. That's what we'll see. Right? Are you following now? Okay, but now if you take a metal which is cubic in shape, and you hit it, what will happen? Will it become this? Will it be shattered? Never. Instead, the highest it can go, or the furthest it can go, it will probably become let's say flat. Do you get? It will probably become what? Flat. Do you get the point now? So now, what property is responsible for that? Why does it become flat? Why was it not converted to a granulated form? And it's simply because of the property known as what? Malleability. So the answer here is malleability. Now allow me to talk about what ductility means. Ductility. When they say ductility, what do they mean? It's simply the property, or the property of a metal. Do you get that? Or is the ability for it to be drawn into shape. Do you get? Is a special property possessed by metal. I get it. For it to be drawn into shape. For instance, your house wire, the wire in your houses, right? Those wire were produced simply because of this property, which is what? Ductility. Without that, your wire cannot be produced. So whenever a wire is drawn into shape, right, ability of an atom, metal, I mean to say, of a metal to be drawn into wire. So that's what ductility is really all about, right? But malleability simply means the ability of a metal to be beaten into shape. Do you get that? The ability of a metal to be beaten into shape. That's what malleability is all about. I'm very sure you understand what conductivity is, right? That is ability to transfer heat and electric current. Do you get that? That's what conductivity is all about. And lustriness, the shining property, let me put it this way, the shining property of a metal is really what is known as what? Lustriness, right? Lustrousness. So it's very straightforward, right? I hope this clear. If it's not clear, please comment in the state where you are confused in the comment section, right? And we'll get back to you. Okay, the next question. Which of the following substance, right? Which of the following substance does not exhibit metallic bonding? Wow, this is a very simple question. They ask that which of the following substance does not exhibit metallic bonding. Now, what criteria must a particular substance exhibit or possess before it can be regarded as metallic bonding or possess metallic bonding properties? Now, it must be metallic. That's the first one. It must be a what? It must be a metal. Do you get that? It must be a metal. A non-metal cannot possess metallic property. A non-metal cannot possess metallic property, right? Okay, so now, first of all, let's identify the metal. Let's identify the metal. This is a metal. This is a metal. This is a metal. This is not a metal. This is a compound. This is the compound. And what our compound is this, right? This is NaCl. That is an association or a combination of a metal and a non-metal. What's that? What kind of bond is this? An ionic bond. An ionic what? An ionic bond. So now, if you are asked which of the following substances does not exhibit metallic bonding, what should the answer be? Definitely sodium chloride. This is the answer. I hope that's clear. Alright, so this is the answer here. Okay, next question. So we are asked that in metallic bonding, electrons are dash. Now, how did I describe metallic bonding when I was teaching it? Please refer back to the previous video if you don't get all my explanation, because I have explained ionic bonding, covalent bonding, coordinate bonding in details. So let's say these are metal, right? These are how metal looks like, and all these guys are actually atom. What I am shading, what I'm putting now, all these dots, right, are known as the nucleus. Right, they are known as the nucleus, and then we have electrons, right? Electrons, just the same way here, the same stuff. So this is how it really looks like, right? And one thing unique about metallic bonding is that this stuff, this guy, this electron you see here, can actually transfer to this point, right? They are free to move to any point they feel like going, right? So that means when we are describing the electron in a metal, we always say that they are delocalized. They are delocalized. I get it. So ability to move from one spot to another spot. Do you understand that? So ability to move from one spot to another. Do you get? So that's exactly what metallic bonding is really all about. So you know, when you share something with somebody, it's actually the bond between two of you can actually be greater. Do you get that? Right? Just for instance, now if two of you are using the same bucket, or this isn't a good scenario, but okay, you guys are in the same bank account, I guess most likely you guys will be always together because you want to know what the second guy is doing, right? You don't know what the second guy is doing. So that's exactly how we picture this. You get? That's exactly how we picture this. So metallic bonding. Now let's read the options. In metallic bonding, electrons are shared equally between atoms. Is that true? No. When they are shared equally between electrons, it's called what? Covalent. It's called covalent. Now transfer from one atom to another. What's that? Ionic. Okay. Delocalized and free to move throughout the structure. It's similar to what I just explained now. So let's check the last option. Shared exclusively between two atoms. Is shared exclusively between two atoms, right? So what do you think the answer is actually what? C. As simple as that. The answer is what? C, right? Alright, let's go to the next question. Now they asked, coordinate bonding occurs within dash. What's coordinate bonding? Now, coordinate bonding is a kind of covalent bonding whereby electrons are shared. but the bond or the electrons used in forming the bond is contributed by only one of the atom. So let's assume that we want to buy a car. So we want to buy a car, right? Okay, this is my car, right? And then we have party A and another guy. If this car is worth $2,000 and this guy contributes $1,000, $1,000, why this guy contributes $1,000 too, what do you think will happen? They will definitely purchase this car, right? They will definitely purchase this car, and both of them will have equal right to this car, right? This guy can take it out, the other guy can also take it out. I guess in this kind of scenario, whenever something like this happens in bonding, we call it a covalent bond, right? This guy is called a covalent what? Bond. A covalent bond. Okay, but now let's picture another one whereby only one of the guy, that is, this guy is cancelling his money. He says he's not contributing anything, right? But this guy is now contributing $2,000 now, right, to purchase this car, and also they still have equal right to the car. You get this kind of bonding, right? If this kind of stuff happens, is known as what? A dative bond. A dative bond. So I can call this particular person a donor, right? Because he's donating all the money. Why this guy? I can call him an acceptor. Do you get the point now? Okay, now, so now this is the first option, which is electrons are shared equally between two atoms. No, that's not wrong. That's wrong. So electrons are transferred from one atom to another. Okay. Both electrons in covalent bonds come from one atom. Now, this is more direct, right? This is more precise. Now, let's look at the last option. One atom donates both electrons in a covalent bond to another atom. Both. Now, what do you think the answer for these will be? I need it to be smart as much as possible. What do you think the answer will be? The first one said electrons are shared equally between two atoms. That's wrong. That's ordinary covalent, right? Now the second one, they said electrons are transferred from one atom to another. Whenever there is a transfer of electron, what really happens? What do you think happens? That's what? An ionic bond, right? Both electrons in a covalent bond come from one atom. This is very close. Now, but the third one keeps us in suspense, right? Now, the last one now. One atom donates both electrons in covalent bond to another atom. That's the correct answer. This is the correct answer. Now, let me give you a very good example so you'll be able to relate to what I'm saying. So, for this one, D is correct. Now, let me show you what I really mean. Now, do you remember something like this? It comes from NH3 and H+. It comes from NH3 and H+, isn't it? Okay, if you look at the structure of this, you will notice that it looks something like this. I guess, and two bond here. Why this has an empty shell? Because of it has lost one electron. Do you get that? So the bond will form, mostly be formed between them, but this lone pair is what is actually forming the bond. That is transferring from this guy to this guy. Do you get? That's why they said here that one atom donates both electrons, the lone pair of electrons. This is talking about the lone pair of electrons, right? In a covalent bond to another atom. Do you get the point now? Alright, so the last question for today. Alright, so in covalent bond, the atom donating electrons is called the, I've basically explained it in the other one. The atom donating electrons is called what? The donor. right? While one racing is called what? The acceptor, right? Take note of that. All right, thank you so much for staying with us. We really appreciate. And any video will be dropped very soon, so ensure you watch it, share, right? Share. When you share, you're helping us indirectly, right? Like, subscribe, comment, and if you have any requests or if you want us to explain any topic for you, just comment that in the comment section and we'll do just that, right? Thank you for so much staying with us. God bless you. Bye.